Hi everyone, Krishna this side. So in this video, I'll be covering this LeetCode problem 1695, maximum eraser value. Okay, let us quickly go through the problem statement. You're given an array of positive integer nums. Array is basically given to us and want to erase a subarray containing unique elements. Okay, so yes, subarray is something what we have to erase which contains only unique elements. The score you get by erasing the subarray is equals to sum of its elements, right? The score definition of score is basically whatever the subarray that we have picked which contains unique elements. When we add all those elements, the sum that we are getting is the score. So we have to return the maximum score that we get by erasing exactly one subarray, correct? So individual element can be a subarray, the entire array can be a subarray, right? We have to make sure that the subarray that we are picking, it has all the elements unique, and when we add them, the sum should be maximum sum. That is something what we are getting it, correct? When we look into this first example, 4 2 4 5 6, I cannot pick this subarray, right? A subarray is continuous uh, form of all the elements that are there, whatever the range that we are considering from 0 to last index, or for first index to the last index, all the elements that are there in between, those elements should be available in the subarray, right? So we cannot skip any particular element and we can generate a subarray. Okay, that is not the definition of the subarray, right? So yes, obviously from this given first example, I cannot pick this 4 to 4 because 4 is getting repeated. So yes, 4 is something what I have to omit this. And when we consider this range from 2 to 6, correct? From 2 to 6, in this particular range, we don't have any repetitive elements. And when we add them, sum we are getting is 17. So yeah, this is the best answer that we can get it. Apart from this, when we consider any other subarray like 2 to 4 or 2 4 5, correct? This sum is not giving us the maximum answer, that is like 17. Okay, so 17 is the best answer. So we have to pick a particular subarray which has all the unique elements and its sum should be maximum. Okay, the question is pretty much clear. Let me connect the screen and I'll explain you like how we can solve this one. And here in the constraints, the values are basically this way. So based on this particular constraint, we can further optimize whatever the first logic I'll explain you. I'll easily explain you like how we can optimize the code as well based on the constraints. Okay, so it is really important to look into the constraints as well every time. Now let us focus on the screen. Let us say that this is the array that has been given to us. From this array, we have to pick subarrays which gives us the best answers. Okay, so the first is like this is the subarray that we can have which gives us the sum as a I mean it could be a maximum sum as well from this particular subarray. So the answer we are getting it is like 4 plus 3 plus 7, that is 14. Okay, from this particular first subarray, 14 is the answer that we are getting it. Then this is also another subarray because 4 4 I cannot overlap simply. This cannot be chosen. This 4 is basically already available, so I cannot pick it in this particular subarray. So from here also 14 is the answer that I'm getting it. Okay, next is like I cannot pick now again like this way. 4 is already available in this particular group and this particular group has been given me answer. So yes, this cannot be part of this particular group or any of the other group. So from 4 I need to get another unique sum, right? So yes, this can be another subarray which has all the unique elements and its sum is basically 17 plus 4 is basically 21. Okay, 21 is the sum that we are getting it, right? And 21 is the maximum sum, correct? So yes, we have to return this 21 as an answer. So from this one, it is pretty much clear that we are just trying to see in a window. Okay, in a window only we are checking that whether this sum is basically giving us the best answer or not. So at any point in time, whenever the sub array time of kind of terms is mentioned in a given question, we just have to think about whether can we apply sliding window technique and can we apply two pointers approach in these given questions. Okay, so that is the bare minimum. Whenever we are trying to solve any subarray kind of questions, you should first try whether you can solve it with the help of two pointers approach or with the help of sliding window, because I cannot sort this data and pick unique elements. This is not a subsequence kind of questions, right? When we sort the data, definitely indexing may get affected on that one, and we are not sure that whether whatever the elements that we are picking, those are part of any subarray or not. Okay, so definitely we should think of using the two pointers approach or the sliding window technique. So here we will use two pointers approach and we'll keep on checking that whether the sum is basically given window size, if it is actually giving us the maximum sum or not. For that, initially what I'll do is I'll create two pointers right over here. Basically both the pointers are left pointer and right pointer initially pointing at the 0th index, and right pointer all the way go to the last index. The moment we reach to the last index, we are done. From this particular given array we may get the answers. Okay, so that is the whole idea. So we have pointed these two, two pointers initially at the 0th location. Okay. Now, whatever the range that I am considering, okay, these are the elements that we have considered so far. We need to keep track of whether any next number that we are getting, whether it is a part of this given group or not. For that, I'll create a hash set. Hash set basically easily tells that in big O of one time whether that element is available in my group or not. Okay, so I'll maintain a hash set which basically keeps on tracking the new elements that are coming, and it basically tells that whether this new element is part of previously group or not. Okay, so that is the use of hash set. So I'll maintain a hash set right over here. Okay. Now, next is like sum is something we are actually keep on tracking. So sum variable I have created right over here, and max sum is also something which I'll keep on maintaining. So this sum basically tells this window sum, or this window sum, and this max sum basically keeps on tracking like which sum basically gives us the maximum sum. Okay, so these two different variables are also required for us. So initially both the values are 0. Sorry, this maximum and sum, both these values are basically 0. Okay, these are the bare minimum things that are required to solve this question. So let us focus now on how we can solve this one. So initially sum is basically 0. So we'll keep on checking this whether this particularly 4 that we are having, if it is a part of hash set or not. That is the first thing that we'll check. So no, it is not available in the hash set. So we will put it into the hash set and we will add it into the sum. Okay, that is something we will keep on doing. And the sum, whatever the sum that we are getting it, we will keep on checking whether the max sum is actually less than this sum or not. If so, the max sum will get updated. So max sum is now 4, and this sum got updated to 4. Okay, sum got updated to 4. Few options we are doing it, three things we are doing it. We will first check that whether this 4 is actually part of this hash set. If not, we will put it, we will add it into the sum, and max sum is something we will keep on tracing out, like whether we are getting maximum sum so far or not. Okay, and then once it is done, right pointer will point at this location. Again, we will do the same operation, check that 3 is available in the hash set. If not, put it into the hash set, add it into the sum. Okay, previously sum was 4, now sum got updated to 7. Okay, and max sum also got updated to 7 because max sum was 7. So this got updated. So this max sum is basically max between the sum, whatever the sum that we are getting it, and previously whatever the max sum so far we got, that is the value it basically holds. Okay, I guess this idea is pretty much clear. Now we are done with 3. The pointer will shift at this location, right pointer. Now again check that this 7 is part of this group. No, it is not. So put this 7 into this one, add it into the sum. Sum got updated to 14. Max sum also got updated to 14. Okay. Now the moment right pointer reaches at this particular location, it says that we are first checking whether it is part of hash set. So it says that yes, hash set has this 4. Okay, that means this particular range that we have so far checked, we got its sum as well with that one. Okay, it's some we already traced out. Now again, we cannot consider this 4 as part of this group. Okay, we have to make sure that this 4, wherever it is occurring in this particular group, till that all the elements should be removed. Okay, for that this left pointer will get utilized. Now the moment we get to know that this 4 is actually available in a group, we will simply run a while loop. Inside that while loop, we will make sure that this 4 should get removed. So whatever the current element set, if it contains into this set, okay, if this right pointer element, that is like 4, right pointer, if it contains this, whatever the nums of right, if it is containing, then we have to make sure that whatever the left pointer is basically pointing, we will subtract it from the sum minus equals to nums of this left. Okay, that is the first thing. And we have to remove it from the hash set as well. Set dot remove this nums of left. Okay, nums of left is something what we are removing, and left pointer we will keep on incrementing. This particular while loop we will run the moment we realize that this element is available. Whatever the current right pointer element that we are pointing at, if it is available, this 4 is available, so we are just performing this operation. If it contains this right element is available, nums of right, then what we are doing, we are subtracting it from the sum. So 4 is something what we are subtracting, we are removing it from the set, and we are simply updating the left pointer. Okay, so this operation is something what we have to do. So how it looks like, so 4 left pointer currently pointing at this number, so number is something we have removed from the hash set. 4 got removed from the hash set. Okay, that is the operation we are done, we have done. Now sum is something we are subtracting it. Sum minus 4 is basically 10. 10 is the sum that we are getting it. Okay, now 10 is something the sum that we got it. So sum got updated, max sum will not get updated with this one. Max sum is 14. So for maximum sum 14 is something what we got it, so it will be same as it is. Now again check that this while loop is something what we are running it, right? So it will get it will not get satisfied until unless it will remove this 4 from this hash set. Okay, now again check that whether 4 is available in the hash set. No, no, it is not available. So what we can do, again, whatever the previous operation that we are doing, this while loop gets stopped, left pointer got incremented and it was pointing at this particular location ultimately. Okay, and this while loop gets stopped, 4 is something we will put it, this whatever this 4 is there, we will put it into the hash set and we will add it into the current sum. So current sum got updated to 14. Okay, 4 is something we are updating it. Same operation we are doing it. So 14 is the sum that we got it. Max sum is basically same because 14 and 14 are basically same. Okay, so now 4 got added into this one and that is done. So the operation is done. Now right pointer basically points to this particular location. Correct? Right pointer is pointing at this location. So again we check that. Okay, again we check whether this 4 is available in this hash set or not, and it does, right? 4 is actually available in the hash set, and this particular range is something what we are considering, right? 374, that is something what in the hash set also you can notice it, and its sum is also 14. Previously this is the maximum sum that was giving us, and max sum got updated, and based on that we were having range. So 4 is something we have removed, and this is the new range that we were having. Again 4 is something we are getting it. We have to make sure that until and unless 4 is something we have removed from the hash set, we will do this particular operation. Okay, so yes, if hash set contains these nums of right pointer where it is pointing at, so we'll keep on subtracting this left pointer sum, and we will keep on removing the left pointer's number from this hash set. Okay, the first thing is like we will subtract from the sum where the left pointer is pointing. So here 3 is something we will subtract it, and we will remove 3 from the hash set. Okay, so this value is basically 11. Okay, sum got updated to 11, right? And now again we check that whether this so this will keep on running it until and unless 4 is something we will remove it from the hash set. Left pointer will keep on incrementing. Left pointer is basically pointing at this particular location, correct? And again this 4 is basically we are checking it in this while loop. So 4 is still available in the hash set. So what we will do, wherever the left pointer is basically pointing, that is something what I want to remove from the hash set. So 7 is something we are removing from the hash set, and we are subtracting 7 from this one as well. So from 11, 7 is something I have subtracted. The answer is basically 4. Okay, sum got updated to 4 now. Sum is basically 4. Okay, left pointer got incremented based on this while loop. Based on this while loop, left pointer got incremented. Correct. Now again, still the 4 is available in the hash set. Still this 4 current right pointers 4 is available. So this while loop keep on running it until unless 4 is removed. That is the whole idea, right? The sum minus this nums of left. So it is basically ultimately 0. Sum got updated to 0. Correct. And maximum will not get updated because 14 is the maximum value that we can get it, and we are removing the 4 from the hash set as well. Okay, now again if we check that whether this 4 is available, now it says that no, I don't have any 4 in with us. So the whatever the previously we were doing it, the operations, that is something what we have to do. The 4 is something we will put it into the hash set, correct? Now whatever the previous sum that we were having, 0 was there, so we will add it into this one. So sum was 4, correct? Sum was 4, max sum is going to be same, right? So why we are doing this operation, right? So we are just considering these windows. The previously this was the window that we have considered. Before that also this was the window, because these all the elements are unique. Now in this particular range all the elements are unique, correct? So we have to make sure that any element currently it was pointing, that element should be get removed from the window. Now when we are at this right pointer, when it was pointing at this one, the previous was this one. So I have to make sure that all these elements should be removed from my sum, then only I will get correct appropriate sum, right, going ahead. So left pointer and right pointer both were pointing at this location. Okay, left got incremented ultimately at the last. Okay, now 4 is something we have put it into the hash set, and we added it into the sum, correct? Now the right pointer gets shifted at this particular location. Now we check that 8 is available. No, 8 is not available in the hash set. We put it, we add it into the sum is basically 12. Now again right pointer got incremented. Right pointer is basically pointing at this location, correct? 9 is not available in the hash set. 9 is something what we have added it. Total sum is basically 21, and 21 is actually greater than this 14, correct? So 21 is something we will update as a max sum, and ultimately this max sum is basically we want to return. So that is something we can return because right pointer pointing at the last index. So this basically tells that now this particular whatever this new window that we are having, these are all the elements are unique, and this element sum is basically we are getting as a maximum sum. So we have to make sure that whatever the previously elements that are there, we have to remove it, those who are giving us a I mean duplicate values, right? 4 are duplicate, so I cannot pick any elements from here, so that from this particular range only we may get the best answers. So this left pointer will keep on incrementing, and this while loop is basically an loop which basically keeps on removing whatever the previously sum that we got it, the numbers sum we will keep on removing it, and we will keep on removing the elements from the set as well. This way uniqueness will be there and we will get a maximum sum as well. Okay, I guess the approach is pretty much clear. Let us now focus on the screen and let's try to write down the code as well quickly. And then I'll slightly optimize the code as well. So here HashSet is something what I'll maintain. HashSet is like basically it is holding integer values, and let's name it as set new HashSet. Okay, now in the once that is done, we have this left pointer basically pointing at 0, and I'll create for loop for int right pointer equals to 0, right less than this nums dot length. Okay, all the way we are going from 0 to last index, right plus plus. Inside here first is like, let me retrieve the current number. Current equals to nums of this right pointer. The first thing is we will check whether this while loop contains whether this set contains this current number or not. Okay, so if set contains this current number, okay, if it is available in the set, whatever the current element that we are having. So initially at 0 location set was empty, so this while loop never runs. But at any point in time this current number is available in the set, we have to make sure that we will remove it and we will keep on subtracting it. For that, like, let me create a sum which is 0, max sum that is also 0. Okay, so here from the sum I have to remove. So let me get here previous element also, and that is like basically nums of this left. Okay, nums of left. Okay, so sum from sum I'll simply remove this previous. Okay, and from the hash set also set dot remove this previous. Okay, that is something what we will do, and keep on incrementing this left pointer. All right, so that is the operation we will do. So until the moment this whatever the number that we are current number, if it is removed from the set, we are done. So we will put that number into the hash set. So set dot add this current number. Then in sum also we will add it, sum plus equals to current, and max sum will get updated with max sum equals to math dot max, whatever the sum that we are having, and previously max sum that we will have, max sum. Okay, so that's it. Like it will keep on doing what are the operations that we were doing it, and ultimately we will return the max sum. Okay, so let us try to run this code. Let's see if it is working fine or not. It is getting accepted. Let me try to submit this and see if it is working fine or not. It is working fine. Now further, when we look into the constraint, right, like here the nums of y, whatever the numbers that are there in this one, they are ranging from 1 to all the way to 10 to the power 4. Okay, so whenever we see any constraints, like these numbers are ranging from 0 to 10 to the power of 5, in this range if numbers are there, instead of using the hash sets or using hash map kind of things, we will maintain a frequency array, right? Whenever we try to solve any characters values, right, and it basically contains only 26 letters, like from small a to small z, or capital A to capital C, or only 256 characters starting from 0 to whatever the ASCII character 256. If that is the range that we are having, we will simply try to use frequency array instead of this hash sets, because also this hash set gives us whatever the element that we are retrieving it from here, it does gives us big O of 1. Like whatever the element that we are trying to retrieve, it does gives us in big O of 1 that element can be easily retrieved. But the problem with the hash set is internally it basically works with the help of hashing techniques. Okay, whatever the hashing techniques it does use, basically with that retrieving of element is basically it does says big O of 1, but sometimes internally it has to do I mean whatever the hashing that it is there, if it gets maxed out, then it has to rehashing these numbers. So multiple operations it does have to do. So this way whatever this number of big O of 1 that is something what it is saying, it will get updated as well. Okay, so it is not fixed. Like if it is saying big O of 1, it is not going to be big O of 1 as well. And internally whatever this int data that we are trying to store, right, so it basically has to convert into the integer type of objects. Okay, then only it can perform that operations, right? So these are the different things that it has to do internally, and this way it slows down a bit. So instead of this hash set, what we will do is we will use a frequency array, because the range is actually less than this 10 to the power of 5. So if range is basically less than 10 to the power of 5 and we want to use the hash set, instead of that we can basically rely on this particular technique like frequency array. So I'll create a frequency array, and new frequency arrays, this length is like 10 to the power of 4 plus 1. Okay, whatever this range is basically there, because these are the numbers which can easily fit into the frequency array. Okay, that is acceptable range. So we will use frequency array, and instead of this set dot contents, what we will do is frequency dot this current. If it is actually greater than 0, okay, then only we will keep on subtracting this previous num, and from this instead of this set also, frequency of this whatever the previous is there, we will keep on decrementing it. Okay, that is the operation that we are doing it. And when we are adding it, that means like we will simply inside this frequency of whatever this current, we will increment its counter. Okay, at any point in time, whenever the frequency of counter basically greater than 0, that means the previously this current was actually available in the frequency array. So we will keep on subtracting, and we will keep on reducing the whatever the previous element that was there in the frequency array. That is the operation we are doing it. So this also gives us in big O of 1, and it is actually faster than the hash set. Okay, that is the slight modification that I have done right over here. This should also work perfectly fine. And yes, it is working fine. Let me try to submit this code. When we see that it is actually working better than what was the previously hash set technique, right? So it was obviously, it basically works better than hash set. Okay, so whenever the constraint, the range is actually pretty much small, less than 10 to the power of 5, we can use this frequency array at any point in time. Okay, so that is all about this particular one. I hope you get the understanding. Thank you for watching this video. Bye bye.